Today, this video will cover the last part of the series for the chapter 10 discussion, which covers complex annuities. And for this presentation, we will be covering deferred complex annuities and deferred perpetuities. Before I start, let me turn off muna my camera para di mag-agaw ang ilahang signal. Okay, let's start. So, I know that guys, you're familiar with, let's just separate our part 3A and part 3B. Actually, this is part 2. Yeah, just stick to that. Okay, so again, I know that you're familiar with deferred annuities. Deferred annuities happen when before the actual payment starts, there is what we call a period of deferment. Okay, so let's dive directly to how our reference book solves deferred annuity problems. So again, it's the same with for our future value of deferred ordinary, or the future value of deferred ordinary complex annuity, and we also have our future value of deferred complex annuity due. This is the same with our, what do you call this one? This is the same with our, what do you call this one? This is the same with our future value of ordinary complex annuity and with our future value of complex annuity due. So with that, let's just copy this formula. And we'll just have to add another letter here. Same with our, oh, let me copy my formula as well. And then we'll add another letter here. Then same with our deferred complex annuity due. This is the formula for that. And then my formula. Okay. Okay. Now, oh, this is not it. I'm sorry, guys. This one. I copied the correct formula. Yeah. Yeah. Except for this one. Okay. Delete this, and then let's transfer this upwards. Okay. So let's now dig direct. Let's now have our sample problem. So the sample problem as illustrated in the book is this one. Not that one. Okay, this one. Find the future value and present value of an annuity of 150 pesos payable quarterly for 20 payments if the first payment is due at the end of 15 months and money is worth how much is it? 6% compounded semi-annually. Okay, so let's identify here our food or the necessary information. So for payment, our payment is 150 pesos. Our I norm is 6%, which means our I here is 6% divided by 2 because it is compounded semi-annually. And then for our n here, or well, this is for our n here, or the total number of payments, that's 20 payments, not percentage. No. General 20, and our C here is again how many our what do you call this one? Our number of months per um what do you call this one per number of months for our compounding period. This is this is some anyway the 6 months, and then this is 6 months, yeah, and then our number of compound of months per payment period, that's how much payable quarterly. So that's 3. So our C here is 2. Okay. Oh, this is yeah. So our MC now is 20 times 2. Right? Right. With our formula. Let me go back to our formula. For C, okay, this is number of months per payment period. Oh, this is inverted. I'm sorry. Number of months per um, payment period. So that's 3, and then we divide that by the number of months per compounding period, which is 6. So that's 1/2 or 0.5. Now, since our formula for the fair future value of ordinary compound annuity and future value of complex annuity due is still applicable in this in deferred annuities, because here we ignore our period of deferment, because what's the concern here is just the final amount. So with that, you can we can directly solve for our future value. So our payment here would be 150 pesos. And then our I here is 0.03, and then we raise that to our NC, which is 40 plus 1. This one is 0.03, and raise that to our C, which is fraction design. 1.5. I think it's 0.5. Okay, minus 1. Okay, so if we input this on our calculators, I hope your calculators are ready. If it's not, you can pause the video and get your calculator and proceed later on. That's another 1.03 raised to the power of 1/2 minus 1. Okay, so we should get 22,788.78, which is, oh, wait lang. What happened here? Bakit iba? Wait lang ha. Because we used 40. This is wrong. Because our NC should be 20 times 0.5. This should just be 10. My brain is scattered. Where? Okay, 10. Okay, so our answer should be 3,464.77. Now let's proceed on my way of solving things. Let me solve for my IE first. Okay. Oh, oh my god, what am I doing? There. So solving for the IE. So original compounding period, so that is semi-annually. Anyway, guys, this way of solving for your equivalent interest rate or compounding period can be used whether your C is greater than 1 or it's less than 1. Okay, so payment period is quarterly. So here, place this here. So we know that our I here is 0.03 and our M is 2. So we should get 1 plus 0.03, and we raise that to 2, then we deduct, deduct 1. Okay, 0.0609. Okay, now on your calculator, simply store this to A, 2 minus 1, which is less. So I'm pressing now shift, store A. So 0.0609 is already stored in my calculator on my button, on my A button. And then here, so our 1 plus I here is, our I here is unknown, but we know that our M is 4 because it is quarterly. And then we now know that we proceed now to substituting IE2 with our value of 0.0609, which is the one that we calculated, which is the effective interest rate. And then, what else? Okay. And then we now transform this formula into an expression where I is the unknown. So we transfer, okay. So here I will be left behind. And then, I know, let's not go there yet. Go here, Moon. Okay. Okay. So, and this one will be transferred here. Okay. So if you would ask me, sir, what happened? So as you can see, we have transferred our -1 to the other side. That's why we have this expression. Okay. And then now we will solve for I. Oh, no. Okay. So I will be left behind here on the left side of our equal sign. So that's I. And then we'll go directly to having the fourth root. Having the fourth root of 1.0609, which is the 1 plus 0.0609, and then on the outside of the radical sign, we less 1. Okay, because after we transfer the 4 here and it becomes a radical sign, we then transfer our positive 1 to the other side, which now gives us -1. Okay, so we should get 1.0609, raise that to the power of 1 over 4, and then we deduct 1. So I hope that you, if when you solve this in your calculators, you will get the same answer. Okay, so I'm gonna do what I'm gonna do now is I'm gonna press my shift, store Bravo. So my effective interest, equivalent effective interest rate per period for quarterly is already solved, and I have that stored in my B button. So let me check for something for a while. Okay, so now I'm good with that, and then I'm gonna replace that on my formula. Okay, so the payment is 150. And then our IE is, what's this? 0.014889. Our N now is 20. Okay, and we'll replace this with 1.014889. Okay, so if you would calculate this, so it would look like this: 150 multiplied by 1 plus our equivalent na I, and then we raise that to 20, and then we deduct 1, and then we divide that by our equivalent interest rate per compounding period. Okay, so again, we got the same answer. Now let's go to an annuity due. So what if the payments were made at the beginning of each quarter? Okay, so uh, what if it's made at the beginning of each quarter? Uh, yeah, let's just use this again. Uh, okay, but here on the bottom part it becomes 1 less, and then our 1/2 now will have a negative sign, not that one. Okay, then we delete 3. Okay, so with that, if we solve this using our calculators, let us see what will happen. So that's 150, and then we have a 1.03 raised to the power of 10 less 1. On the denominator, we have a 1 less 1.03 raised to the power of negative 1/2. Okay, so this should give us 3,500.35. Okay, well, on my way of solving things, I hope we will arrive at the same answer. Oh, I forgot to change the patterns here. Okay, same here. Okay, and then uh, and just then add another. Oh my god, another. Oh, not that one. Why is it different? Oh, there we go. And we multiply 1 plus I, which is our equivalent I, 14889. Okay, so if we input that in our calculators, so this one, and then this will be replaced by our equivalent I, same as this one, and then we simply have to add, oh, not the one, simply have to add another multiplied by 1 plus our equivalent I. Okay, so we still got the same answer. Now, the complication comes when the item in question now becomes a present value, because we will be dealing with a different formula. By the way, whether or not you see for a future value, whether or not it's a ordinary annuity or complex annuity due, or whether it's a present value of ordinary annuity or present value of annuity due, your formula will still be the same. Okay, so um, let's go to our second, which is the solving of our uh, present value of deferred ordinary complex annuity. Okay, let's start with this muna. Oh, by the way, if I don't, I hope that you haven't forgotten yet, no? Your on how you solve for D. So our D here is it's for for uh for ordinary annuity, our D is, it would be the period of deferment, which is 15 months, and then we divide that by, let me see here muna kung is it based on compounding periods, or is it based on payments? Also, D now is our payment interval. So that's 15, and we divide that by our payment interval, which is quarterly, so 3. So that's 5. Our D would be, for ordinary annuity, our D would be 5 minus 1, would be minus 1. And then for what do you call this one? For um yeah, for our annuity due, that would be 5. Okay, so that's our D, which is for annuity due we don't deduct 1, so that's 15 months divided by 3. That's just it for annuity due, and for ordinary annuity we have to deduct 1 from it. Okay, and for our PV of the BOCA, the formula is let's see, let's symbol the equation. Okay, so that's PV of deferred ordinary complex annuity okay, and then equal to payment. No, let's use the fraction muna. Payment over, what's that? This would be another fraction. So this would be 1 plus I. Erase that. Oh, wait lang. Okay, so this would be 1 plus I. We raise that to the power of C, and then we deduct 1, and then over I, and then we multiply that to another fraction. This is present value. Okay, so this is present value. So this is 1 less. Okay, 1 less, another like this. 1 plus I. Yeah, and we raise that to negative C times D plus N. Okay, and then over I, and then we deduct from this one the fraction, present value of C times D. Okay, so we'll just we can just copy this one. Okay, so we'll close that in parentheses. Okay, so we have a no, okay, that one. Okay, so C times D. Okay, so this is your formula. Now, can we simplify it? Okay, so yes, we can. So how can we simplify it, sir? Okay, let's do it this way. So let's transform muna this into two separate equations. We transform the division sign into a multiplication sign by inverting this lower part, no? So this will be inverted, and then this will now become, okay, yeah. let's just say this is going to become payment, and then we multiply that by a fraction of the inverse of the denominator, which is uh, this I over this one. And then we delete this one. So the like that. So this expression is transformed into this one. And then for this expression naman, we can combine this two expression because they contain this because they have the same denominator. So this one will be transferred all the way here. So we'll have now a minus bracket. Let's use a bracket. That's one. Okay, and then this will now be deleted. This one will just use the bracket. Yeah, and then this one will use. I think yeah, this is the bracket. No, I don't know. I don't know. I forgot what you call this one. Now, after this, is there still a way that we can actually what do you call this one? Is there still a way that we can simplify this? Yes, there is still a way. So how do we do that? Okay, let's go further down. Okay, so um, let's uh let's multiply muna first this negative sign to this enclosed sign. So negative times 1, that would be negative 1. Oh, 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 oh. Because I put it in a bracket. Or did I? Yeah, I did. So, ma-delete ang tibok na ano. I'll just have to copy this. Okay. Then delete the first, last one. Okay, bawa. Okay, so negative times 1 is negative 1, and negative times negative, this now becomes a positive 1 plus I negative CD. Okay, so after this, let's simplify our equations further. Okay, so now I will be cancelled out. So meaning this will now be transferred to this side, because your I will now be replaced by this whole equation. Because when I is cancelled out, we will now have 1 as our denominator. So we will multiply that to this expression. Muna siya nga siya ang mabilin. And then for this one, mawala po si I, may mo siyang 1. Multiply that to that. So muna siya nga, this will become our whole denominator. So this will now be the ang mabilin sa itong equation. Now also, as you can see here, this is a positive 1 and this is negative 1. So now our 1 will now be eliminated. And for aesthetic purposes, no, it's better to look at equations kasi when mas mag-una yung positive versus the negative. So with that, our final equation would be this one. Yes. So this will be your final equation for your present value of deferred ordinary complex annuity. While for on my part, my equation will still be, what will I use? Yeah, my equation will be this one. PVDOCA, and I'll just simply add here 1 plus I raised to the no, a 1 plus I raised to the power of negative b. Okay, so with that, what else? Hmm. Uh, what else? So now we proceed to solving this problem. Okay. So with this, let's see. Um, let's substitute our given information to this equation. Okay, so that would be our I is 0.03. Our C here is 1/2. So I'm gonna add some fraction here on this top. So that's -1/2, and our D is 4. Minus 1 plus our I again is 0.03. And then raise it to negative C again. This is 1/2. So 1/2. And our D is 4, and our N is 20. Okay, so we go to the lower part. This would be 1 plus 0.03, and uh, then we do our one is our fraction. So this is 1/2 minus 1. Okay, so if we would we would input this. Oh, our payment is, what's our payment? Our payment is 150. So if we would input this in our calculators, no? So this is 150, 1.03, we raise that to, that's -2, right? Because it's -1/2 of 4 is -2, and we deduct from it 1.03 raised to the power of, that's -12, right? Because -1/2 of 24 is -12, all over 1.03 raised to the power of 1/2, and then deduct 1. So we should get 2,430.12. Okay. Now, if you would use my if you would use my formula, hopefully you would still get the same answer, no? So, yeah, let's use this. Okay, so our payment is 150. Uh, Mind you, our IE is already solved on the top, which is this one. Let me just copy this on the lower part. Oh my God. Okay, so yeah, our IE here is 0.01. Okay, that's 0.014889, and this is 0.014889. Our end here is 20, and our this is 0.014889, and our D here is 4. Okay, so with that, if you would, okay, let's just solve it here. 50. For you to use this again, we first have to solve your equivalent interest rate per period. Okay, and store it on your calculator. So that's 1 plus our equivalent I. Oh, this is one less. Sorry, this is one less. 1 plus our equivalent I, and then we raise that to -20. Yeah, and we divide that by our equivalent I, and then we multiply that by 1 plus our equivalent I raised to the power of -4. Okay, so with that, oh, what happened here? 1 plus this one. Okay, so Did we get the same answer? Yes, we did get the same answer. Okay, so now let's proceed to when our when the when the problem is an annuity due. Okay, so actually I'm not familiar with the formula for the annuity due, but I believe the formula for that is this one. Hopefully I'm correct, huh? Hopefully. Let's just hope for the best. TV of cat here. Deferred complex annuity due. Deferred complex annuity due. Okay. So I'm just guessing this formula based on the complex annuity formulas, uh, complex ordinary annuity formulas. Okay. So if we will be, oh, not this one, this one. Why did I copy that? Okay. Let me move you first. First here, and then I'll move you up that. So this is one less, and this will become negative c. Okay. Okay. So if we input this information on our calculators, we would get this is 1 less. And this is negative 1/2. And then oh, no, 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 no. Okay. So then we would get our by the way, our D here again, when it's annuity due, our D here now becomes 5. So I have to change this. This is annuity due. So 5, and then this is 5. Okay. So now that becomes 2.5, and another that would be 12.5. So this should give us, yeah, actually. This should give us, actually, should be the same amount. Whether or not it's annuity due or whether or not it's annuity due or ordinary annuity. Yeah, this is the thing with deferred deferred annuities, whether or not, except for the future value, but for the present value part, whether or not whether or not the problem is a due or an ordinary annuity, probably you would actually arrive at the same answer. Okay, so this will my formula then here will be x times 1 plus I. Now remember, when you multiply like terms, so this is considered like terms because they have the same base. This is 1 plus I. You can now combine them. So now this becomes, oh no, oh, five. Okay. So now this becomes times, so our exponent for 1 plus I is positive 1, so that's why we have negative d, and then we have plus 1. Okay, so if you would look at this part, guys, no, our d here for ordinary annuity is 5 minus 1. But for our annuity due, it's the whole period of deferment without deducting one period from it. Well, so it, and then when you translate that to what we call this one, to a formula, to when you translate that into an equation, your d here will still be subtracted by 1 because negative plus a positive number will result to a subtraction. So negative d plus 1, so it will still result to 4. So with that in mind, um, your the when we replace the values, it should look like this. Okay, 20, and then this would be negative 5 plus 1. Okay, so with that, we solve for when we solve for the amount, so this would be this one should be our equivalent I, which is this one. In diri siya nga part useful tong inyong kuan guys sa store function in your calculators. Now again in our in our exponent for this part, this is negative d, which is our 5, and then we add 1. So essentially we'll still arrive at the same answer. Okay, so with that, and again, guys, whether or not our C is greater than 1 or less than 1, our formulas will still push through, and even in the way that we solve for our equivalent effective interest rate. Okay, so with that, we're done with our deferred complex annuity. Now let's go to our um, or I may just or I think I might cut this off here, and then I'll continue this one to the next video for our deferred a complex or general perpetuities. Okay, so guys, hopefully that you have learned something from this video, and hopefully that I'll see you on the again final na yun siya. I'll see you on the very final part of this series. So thank you again for your time, and hopefully that you have learned something. Bye.